this is Lori with STEM Excellence Tutoring. Today, I'm going to talk about beta elimination that follows an E2 mechanism. For an E2 mechanism, we can have a primary, secondary, or tertiary carbon, but tertiary is preferred. We also need a strong and sometimes bulky base, and we need a configuration that is anti-periplanar. Let's look at a couple examples. Here, we have a tertiary carbon because the carbon that's bonded to our leaving group is also bonded to 3 other carbons. We also have a strong base, so that means we have conditions that are going to favor an E2 mechanism. All of our beta carbons are equivalent, so it doesn't matter which one we choose. So we're going to show a hydrogen on one of our beta carbons, and the base is going to attack that beta hydrogen. The electrons that are in this carbon-hydrogen bond are going to move to form a double bond between our alpha and beta carbons, and then our carbon-bromine bond will break, and those electrons are going to go with the leaving group. This gives us, for our products, a double bond between our alpha and beta carbons, and the leaving group with its electrons. Let's look at another example. Let's look at trans 1-chloro-2-methyl cyclohexane. Whenever you have a cyclohexane, you need to draw the chair conformation because you need to double check for an anti-periplanar configuration. For a cyclohexane, you only have anti-periplanar when your leaving group is in the axial position. So when we do our chair, we're going to start off by putting our leaving group in the axial position right away. Because it's trans, the chlorine and the methyl need to be on opposite sides of the molecule. Here our chlorine's above, so that means our methyl is going to be below. For this beta carbon, our methyl is now in the anti-periplanar position to our leaving group, which means that this carbon cannot undergo E2 elimination because it doesn't have a hydrogen that's anti-periplanar to chlorine. If we look at our other beta carbon, there is a hydrogen that's anti-periplanar to the chlorine. So this carbon can undergo elimination using an E2 mechanism. And in fact, this is the only carbon that undergoes the elimination. So if we bring our base in, it's going to attack our hydrogen. The carbon-hydrogen bond breaks, and these electrons go to form our double bond between carbons 1 and 6, and then our leaving group leaves with its electrons, giving us a cyclohexene with the double bond between carbons 1 and 6. That's a little bit about E2 mechanisms. I hope that helps.